All right, we're back. Advent of Code, day 19. Slight change of scenery here, but it's still me. It's still Advent of Code. We are on the second to last prime number day of Advent of Code. A little bit late. We only have an hour and a half before the the next Advent of Code day kicks off. So we better get this done. Otherwise, we're going to run out of time before another star unlocks. So let's switch over to the code and take a look. So we've got our scene. It's really starting to come together now. We can see the remaining days left over down here for day 25, but we can see the path that our journey has taken. And I still can't really tell what it is that we're seeing, but we seem to have wandered over into this neck of the woods, as it were. So let's prepare to start the stopwatch, and as I go to do that, let me boot up our console and the terminals, import our handy dandy utils, and load up day 29. Close out these three, and reload from disk, and open up day 19 files. It looks like I forgot to commit day 18, so we'll have to do both in one batch today, and we'll run day 19, and there it is. Great. So let's see, let's go back to Chrome now, and we'll start our clock and look at what question 19 has to bring. So 19, monster messages. All right. You land in an airport surrounded by dense forest. As you walk to your high-speed train, the elves at the Mythical Information Bureau contact you again. They think their satellite has collected an image of a sea monster. Unfortunately, the connection to the satellite is having problems, and many of the messages sent back from the satellite have been corrupted. They sent you a list of the rules valid messages should obey and a list of received messages they've collected so far, your puzzle input. The rules for valid messages are numbered and built upon each other. For example, this mess. Some rules, more parsers, like 3:B, simply match a single character, in this case, B. The remaining rules list the sub-rules that must be followed. For example, the rule 0:12 means that to match rule 0, the text being checked must match rule 1, and the text after the part that matched rule 1 must then match rule 2. Some of the rules have multiple lists of sub-rules separated by a pipe. This means that at least one list of sub-rules must match, so it's an OR statement. The ones that match might be different each time the rule is encountered. For example, the rule 2:13 pipe 3:1 means that to match rule 2, the text being checked must match rule 1 followed by rule 3, or it must match rule 3 followed by rule 1. I still don't know what even rule 1 means, like A. What is A supposed to be? Fortunately, there are no loops in the rules, so the list of possible matches will be finite. Since rule 1 matches A and rule 3 matches B, rule 2 matches either AB or BA. Therefore, rule 0 matches AB or ABA, because rule 1 is 1 then 2, and rule 1 is just that it has to be A. So it's saying that the first character has to be A, and then the second characters, I guess the second lexicographical chunk. All right, let's take a look at a more interesting example. Here, because rule 4 matches A and 5 matches B, so that's kind of like the root of our rule tree. Rule 2 matches 4:4 or 5:5. Rule 3 matches two letters that are different, AB or BA. Rule 1 is 4:1:5, matches rules 2 and 3 once each in either order, 2 and then 3. So 2 is either of these, and then 3 is either of these, but also either order, so that leaves that many possibilities. If this asks how many possibilities, that'd be crazy. Rule 0, therefore, matches rule 4, then any of the 8 options from rule 1, then rule 5. Okay, so it starts with A, ends with B, and everything in between is just the rule 1 crap. Yeah, all that stuff. The received messages, the bottom part of your puzzle input, need to be... I really am going to have to... Wow, this is long. Okay, I need to look at this puzzle input. So we have this first part, which is really long, and then the second part, which is even longer. Great. So the received messages need to be checked against the rules so you can determine which are valid and which are corrupted. Including the rules and the messages together, this might look like that. Your goal is to determine the number of messages that completely match rule 0. In the above example, these match, but these don't match, and the answer is 2. The whole message must match all of rule 0. Cannot be extra unmatched characters in the message. A, B, B, B might appear to match rule 0, but it has an extra unmatched B in the end. How many messages completely match rule 0? What even is rule 0? It's just this. Which is that. And 11, which is... Where even is 11? 11. 4231. Alright, so this is going to break down real fast here. Stick this here. Let's grab our biggish input, this one. We'll call it our intermediate input, or small. And I think the first thing we're going to need to do is split on the double new line, our classic two-section split. And we'll do a file.read split on double new line. I think we're going to do a custom parser on this one. I'm not going to use this, and we're just going to... Let's uncomment here so we can edit them at the same time. So I don't want any of that. And just do file name equals and get rid of that. Nice. Then we're going to parse 1, and we'll pass in that file name. So parse 1 gets a file name with open file name as file. We're going to, let's do f.read. Alright, let's read.split on new line. I guess that's fine. Lines for line in lines dot split. Let's do this. Rules and what are we calling the other thing? Messages? Yeah, rules and messages. Rules, messages, and then so for all the rules that will split on new line, rule, we'll do something. We'll be parsing the colons out, it looks like. So we'll do rule.split on colon. So that'll be rule num and rule string. And the other for loop will be for messages, for message in messages dot split on new line. Yeah, so that'll be an easy one. In fact, let's just do a list comprehension here. Messages like that. And let's return rules and messages so we can see it. And I want to return rules and messages, which is what we'll get out of the parser. And so we have rules, which is something like this with new lines, because I haven't modified rules yet. And then messages is one we've gotten these into a list. So that behavior looks right. Let's split the rules up now. The rules need to split by new lines. Then we got a rule number and a rule string. So the rule number I want to be able to look up by value. So let's do a rules dictionary and rules dictionary at rule num, but rule num is a string. We're going to need this to be an int so we can do the proper lookup. We're going to grab the rule string. How should we encode the rule string? This part is a little bit tricky. So the types of values that can show up as a rule string looks like it's only ever a single OR, and it's always two values after each other. So we can split on the bracket, and there's always a space after the colon. So I'm going to include that space in our code here, and I want to do a quick check to ensure that when we have something like this and we do split on bar, we do get what I hope we get. Okay, so it doesn't make like an empty string or something like that. That's what I was worried about. And since we already searched for the space there, we're only going to end up with something like that. So like this, split, we're expecting something like that. And the splits always have a space around them. So if we split with spaces around it, we should get a clean take, which we can then split on space and separate out the numbers individually. This still doesn't address the major problem here of the two-parter. How should we walk these rules? That's the main problem. How do I want to? Because I'm reading through this and I didn't. Maybe I wasn't paying enough attention here, but like I don't have an immediate kind of intuitive grasp on how I want to do the rule matching, especially with these multiple combinations. I suspect that we're going to have to either try to come up with every single possible combination based on rule 0, and then match the inputs to all of those combinations. I suspect, based on the number of inputs given here, that's going to be way too many. And so instead, what we want to do is, given an input, try to match it to the rule set, letter by letter. But even in doing that, we're going to need some way to represent these strings, basically, right? These rules where it's like, rule 0 says we have to go to rule 4, which is an A, and rule 1, which is, this like amorphous kind of could be, could not be, any number of things situation. And then 5 is like fixed again. So given the number of rules provided, it's going to be infeasible to do this by hand, for sure. If we try to unwind the whole thing, right, like if we were to rewrite this as kind of a flattened version, we could end up with something, okay, with something like, we had 4, 1, 5, and then 4 gets replaced with A, 1, 5. 1 is then 2, 3, or 3, 2. I'll put it in parentheses. Not that I want to use the parentheses parser from yesterday, because that would be a nightmare. And so that leads us to say that it could be like A, 2, 3B, or A, 3, 2B. And then each of those then break down to be A, 4, 4, B, A, 5, 5, B, or A 5, no, A 4 4 is and 5 5 is just the rule 2, and then rule 3 can be 4 5 or 5 4. Okay, 4 5 or 5 4. How many outcomes is this going to yield? 8, right? Which is exactly what it ends up being. Okay. And so given a string, you know, we get a string and it just says the first letter is A, and it's like, well, I feel like we're going to need like a custom class that represents these rules, basically, these nested rules and their positions. Like in particular, we have this situation where these middle 4 have all of these possible combinations because of the rule matching. And it's like, given a string, how would I even go about determining if it matches a rule, right? You would be like, well, the first rule is that the first letter has to be A. Okay, that's good. Then we go to the next letter, and it's like, well, to figure out the next letter, we need to look at rule 1. We look at rule 1, and it's like either 2 3 or 3 2. So then you look at 2, and then 2 is either 4 4 or 5 5. And then you look at, you know, 4 and 5, and you're like, well, it could be either this or that. Tracking the indices would be rough. And just like building out that rule tree while walking, oh man. Okay, so we don't have to have the full solution in our heads like at the beginning. I think if we can give a reasonable approach to at least representing the rules as printed here in the file, hopefully, this is definitely a bit of a leap of faith thing, hopefully that will get us on the right direction, and we can kind of go from there basically and try to use the, you know, we'll build toward it basically and try to capture this in a rich way so that we can utilize it later. There's always up to one split. And so for the time being, let's have a list of, or a set of tuples. So it'll be a set of 2, 3 and 3, 2. Do we care that it's a set? Like, it's only in the sense that like we don't care about the order, but I'd probably just do an in anyway, and a list might be lighter weight. So rule string right now is a string. So rule string, I might need to write a little helper function here, just to like extract rule, or, you know, like parse rule. So given a string, we're going to split that string on bar space, space bar space, like we saw before, and that'll give you the first half and the second half. So that's like A and B. And then A and B themselves are going to get split by space, like that. And so that'll give you A1, A2. And I want to map int onto those two outcomes because now they are truly the numbers, and list. We'll do the same thing for B. And we'll close that. B1, B2. And so what this will return is a list of two tuples, A1, A2, B1, B2. But s.split doesn't always return two things. So let's fix that. Let's say rule list for rule in rule list we're going to do this whole thing for R. And then once we split that, we have this little list. That will always split into two things. So we can call that one R1, R2. And we can make a little list here at the beginning. Output equals this. And for each one, we'll do output append R1, R2 as a tuple. And all of that can go away. Because then at the end, all we need to do is return output. Yes? Yeah. So once we get that as a list, puts it in there, we make a rules dictionary, messages. So now we can, whoops, not that one. I want to try rules dictionary. All right, we got an unpacking error here. Too many values to unpack. Expected 2, but it got more than 2. Huh. Interesting. So let's see what that looks like. Print R. Yes. Because it's just 415. Wow, how did I miss that? So when there's an OR, there's always two things. And sometimes there's just two things. But sometimes there's three things? Where's rule 0? It's two things. Oh, sometimes it's one thing. And sometimes it's a string. Right. Oh boy. Okay. So there's a lot of possibilities here. Really blew it on that one. Rules dictionary. Man, we're going to need a more flexible way of representing these rules. So parse rules, whatever we store, we need to have a way of, recreating here. And so we can say if bar in S, then all of this is valid. Okay. If S at position 0, this is checking for a quote, then we know it's a letter, right? The only times we have a quote are these two actually, are these two, yes. 39 and 18 are our A and B. Man, you could almost just like handle those as single cases, because I think it's just going to be the second letter. It's going to be S at 1 is the rule. And so that would just be a string. Yeah, we'll put that there for now. Ugh, I'm worried about this. Okay, and then there's the no bar version, where it's just a number, which is fine, except when there's just one number, in which case it's not fine. Yes? Yeah. I feel like that one number case is just there to throw us off. Everything else is two numbers. That's so funny. All right, so we got this situation where we can split S on all of its spaces after we split on all of its bars. That's one way to do it. Yeah. Let's do S equals S dot strip. So just clear out any spaces. And we can say we'll split on the bar. Whoops. And then after we split on bar, even in the case where there's no bars, it'll be this. Now we can split on space, which that will still be able to handle. So we'll split on space. We'll get rid of that. This whole thing goes down. Whoops. So we'll split on bar. And then for each thing that comes back, we'll split on space, which will be a list. And we will append that list tuple of nums, like that. How does that look? 0 gives you a list of 4, 1, and 5, whereas 1 gives you a list of 3, 2, 2, 3, and 4 and 5 give you the strings A and B, so we can check types. And we can always index into the value. Okay. It's a starting point. And so when we want to parse a message, we look at the first rule, and the concern I have here is that I still don't have a good way to match a string to the full rule set. Like, I'm not representing the full rule set here. This is like the beginnings of the rule set. I think I need some sort of class that represents a rule with somewhat of a flexible definition of a rule. So something that, rule, and we'll input like the rule dictionary, right? And it'll have some sort of storage mechanism. Yeah, I'm wondering whether I need the whole rule dictionary, or so each rule. Let's have each rule only encapsulate its like portion. So the rule can have, so any given rule, like by the per the instructions here, can only have either a letter, these numbers that are ORed, or these sorts of things, right? So basically they can have whatever the contents of their corresponding value in the dictionary maps to. So we should have an attribute of, like, I'm basically writing a class in this text file now, aren't I? So you pass the rules dictionary and the rule number, right? So at the beginning it'll just be 0. And then rule num, that'll be worth storing. Hey Gabriel, thanks for tuning in. You're getting ready for the tomorrow's, the next one that's about to release, I'm guessing. Rule num is rule num, and then rules dictionary at rule num. Right, that's going to be, in this case, this 415. All right, I think we can start writing this. We have at least a direction to head with this now. We have parse rule, parse one. Let's start defining this class. So, rule, this thing's a real gut punch. So each thing in the rule thing, right, is going to be, well, let's first put like rule. And because I want to check if rule equals in A, B, then, we're stopping here, right? Like we don't want to recurse in any further. So this is our base case. Then self dot value equals A or equals rule. I'm still putting in a list. We'll see how that plays out, and that's it. Return. So otherwise, for R and rule, so now we're going to go through kind of a list like such as this one, right? And we'll say kind of for each value in here, that's like one possible thing that it could be. So it's like the matching value could be this thing. There's always 2 of them. So it's like saying the matching value could be rule 4. So we'll say each one will add like self.value.append, right? Like something like that. We'll set it as in a list. What I'm worried about is I'm basically just remapping the dictionary back to itself, back into this class. It's not like, is it really furthering our goal? Like especially in these cases where it's not the same, right? Let's say it's like 4 and then 5. Sometimes it's just one thing, and sometimes there's 2 things. So what do we say? Value 1 equals that, and self.value 2 equals none. And so then we say if it's not none, then we do something. If it is, we do nothing. So then we can say like value 1 equals rule at 0, and then value 2 is rule at 1. It still leaves us in the lurch with this situation though. Like what we really want is for each of these numbers to basically have it, oh, yes, we want each of them to be its own thing. All right, we're getting somewhere here. We don't want that. We want the value to be a list. That should go above. And we want to append for rule and rule, so that's this tuple. So we're going to say then for rule num in this R thing, we're going to append a new rule, which we'll have to pass the rules dictionary always, followed by rule num. Right? So it's going to hold, like here, it's going to hold the fourth rule number 4, which itself, in this case, will hold A. And so when we have all of these things, yes, just like we saw with yesterday's thing, I might have to pull up yesterday's code. Eval, right? We're going to do kind of for value in self.value v.eval. If self, for each of the things, if v in AB, return v, otherwise return self v.eval, which will go to the value, it'll call the next rule's evaluation. Yes. And so it will return lots of different possible, I'm kind of curious what this will do. I'm not completely seeing it right now. No, I know we're heading, we still need to match it to like the input, like eval should take a argument of like, you know, matching the thing and kind of slicing it down. Take an arg, slice it down, recurse. It should do something like that. But for now, I want to parse file name 1 and create a rule with the rules dictionary. Do we have that somewhere? Rules dictionary is getting returned from parse 1. Oh, we're just calling it rules. Let's call it rules dictionary proper. And then we'll say rules dictionary, and 0. Is that what it is? 0? Yeah. And then we'll do base.eval. Let's see what that gives us. In string, requires string as left operand, not list. Interesting. Right. So what I really want to say is if type rule equals string and rule in AB, requires, yeah, same problem here. If, and really I should be using is instance, is instance, and is instance v, sorry, is instance, so object and the class, okay. V, that's what I thought, I just wanted to make sure. Let's do it right by here as well. So is instance a type of, whoops, is rule type of that, all right. Name rules not defined, no problemo. All right, so print base eval rules, oh, come on. Okay, that's fine. So let's see what we got here. It printed out 41523324455454554 A, but not B. Don't know why it didn't print B. A little concerned that everything else came out this way, but I guess I shouldn't be that surprised. Because when I call rule, do I have any print statements in this whole thing? Yeah, I didn't think I did. Why is it printing so much when I call eval? Is it from print? It's not from calling eval, that's the problem. So printing eval just printed A, I think. Yeah, because it went all the way down and it found the A, and it's like, I'm done. So we need to go through each thing in value. Oh yeah, we just returned the first one. So if for v in self.value. So if self.value it is itself, where's self.value when I have it be AB? So it's still inside the list, which is a little awkward. Maybe I can just make it rule. Then I can say if self.value is an instance of string, then just return self.value. Otherwise, we know this is not an issue anymore. And then we can kind of have a result is a list. Then we can do v.eval result.append v.eval return result, and have it print out A. Ooh, interesting. It's showing all the possibilities. So like look at, so it's saying the first one has to be A, the second value has to be one of these four things, and how many combinations did this say it could be? Rule 1 matches the rule. So we were looking at this. Since rule 1 matches 2 and 3, it must match 2 different pairs of letter, 1 with 8 possibilities. Any of the 8 options for rule 1, then B, rule 5. That's 8 options, not 4. So we have AAAB. Well, let's just look at these. AAAB, and then BA. And we have BB, AB, and BA. And then AB, and then BA. And then it's always AA, BB, BB, AA. Okay. So what am I getting here? I'm getting AABB, ABBA, ABBA again, and AABB. All right, so that's not quite right. And I think the prints from before were coming from the parser. Print rule. Yes. So that was just the rules as we were seeing them. And so we've got our parse, we open, we split on new line, we do the thing. If value is that. All right. So this doesn't intuitively give us the quote-unquote right value, which I guess shouldn't be in itself that surprising because we're not like actually doing it the way we thought we were. So if we take a message and then we say, the first chunk needs to match whatever, and so it's like if when we are at a chunk, I'm trying to define what a chunk is. That's where it gets tricky, right? Like at the first level of recursion where we're saying that our rule num is 0, and it's like I'm expecting 4, then 1, then 5. And so we have this array of rules that are, or values, I guess they really should be called rules, that are kind of like rule for 4, rule for 1, rule for 5. And I could probably get a nice repra in here, which will do self.values kind of rule num, right? That's what we want to show. We want to show rule nums of each successive thing. Yeah. So for each value, show the if because I don't want to get down to just an A. For each thing. Well, let's. So if initially I just say return v.rule self.rule num. Yes, and then we have this problem. And I never actually try to print return non-string type. What? All right. So that just gives us a 0. Yeah, that's true. So that's not going to do. We do v for each thing. We can do its rule num, wrapped in a string. Then we get 4. Why? Like this dot value should be string attribute has v in self dot value. So these are public attributes. Self.value either contains a list of rule classes. Because 4 doesn't have a rule num. It just has, like when it's just AB, it has no rule num. I mean, it does. It's like 4, and then its value is A. So for v, and oh, we want to put the value. Still no v dot value? Which case would have no v dot value? Print self dot rule num. So we do 4, which should contain the rule num for 4, which is just an A. So we say it's in A. We say value dot value is A. Why? The only reason I can see here is if this doesn't come back as a string, which it might not, based on how I switched up how this dictionary is being populated. Trying to remember now. Parse, we just return this, put parse rule, put it in there, put there, we put there. And so now for each rule, that's why we've been saying if the value is a string, we just do that. So do we have to do a similar kind of thing still, even for these? If this return self.value directly, if it is a string. Otherwise, it's not a string, so we need to go deeper, each value thing, and figure out its value. Good. So rule 4 has its value, which is not being shown. I also want to know where this is printing from. I don't think it's here. Oh, that's the rule num that's showing up. Huh. So this is this is that. 415 is giving us this. That's what's giving us that. So when we do 1, it's going into the rule lookup, and it's like 1 can have 2, 3, or 3, 2, which itself is AA, BB, or BAAB. So it should have lots of options, right? So this eval should be the crux of it, basically, right? We should be able to say, given a message, if the rule that we're on is just a letter, then we want to let's not call this eval, actually, because well, it's not like it's not doing anything right now. So what it's returning is useless. If it's just a letter, then message at 0 needs to equal this string, like completely. So we have to return whether or not it equals that string. Full stop. End of story. And what do we do with the rest of the string? Like, do we return what's left, essentially? Because we're going to parse from left to right. We're going to say, like, here, like when we go through, we could say something like, you know, here is, so we take this message, right, like A, B, 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 and we pass it in, and it's like, okay, the first rule, rule 0 has is 4. So here, for, you know, all the rules, here's rule 4. Let's go and call eval on the message, right? And it's going to return valid and the new message that is left. so to speak. And so it should say, it should do the chopping for us, basically. So it's like, we call it down, we say if the first one is the value, well, we know we only need to check one thing. So message, letter, and remaining message. So message at 0, followed by message from 1 to the end. And so now we say return whether or not the letter is the same as the message we want and the remainder of the message. Okay, and then we say result.append. Yeah, forget the append problem. This there's a bigger thing at play here. So don't worry about append. We'll do result.append. We could append the valid each time, right? And then we can say if we can return if they're all valid. And the thing with this message thing, right, is each time we take the message, and we need to do some kind of check first and foremost, like with the double rules and things like that, I think. Ooh, because of the OR conditions. How am I even encoding that? Am I missing that? So given a rules dictionary, we get all of these rules, right? So it's like we've got a bunch of rules and appending the thing that represents the rule. I think this is the problem. I'm not capturing the OR aspect of our situation. So the rule is that entire array, entire list. And within each of them, there is a tuple. So this tuple here, this tuple is an option. Like all the different values, it's like it must match either, like it has to match one of these R's, right? Yes, yes, yes. And I'm appending each of them individually. So it's like I'm appending 2, 3, 3, 2 separately. And so here I appended 4, 4, 5, 5. Like I appended rule 1, which did 2, 3, 3, 2. It's interesting though that it ended up with 4, 4, 5, 5. It took the first one, and I guess it did that and it stopped somehow? Regardless, this isn't quite right. So we'll say we need another list, basically. Right? Like, this is a rule for each of the things in rule. So each of these tuples, we need to make rules based on them. So we have like the rule num is the number that it's coming from. Oh, I'm modifying. I shouldn't call that that. Call it that. Okay. So we're getting the rule. We have so R is a tuple. So R is like all the rules that you like one of the rules, but you have to satisfy the entirety of it for it to count. Yeah. I'm going to have to make this a nested something or another, right? So this is like a rule set. I know it's not a set, but bear with me. And so it's like, this should be rule set dot append a rule. And then at the end of that, we say self dot value dot append rule set. And so we now have nested lists, which in the eval phase, we can say for rule set in value, like for each of the rule sets in value, we need to match at least one of them. So we can go through, what did I used to call this? Okay, V. So for each of the rule sets in value, it's like a whole bunch of stuff. I feel like I need a class for that, but it's okay. Don't have to have a class for everything. For each rule set, for V in rule set, then we say, we find out if it's valid. Rule set valid is a list. And say rule set valid dot append whether it's valid. And so then we want to find out is all of the rule set, are all of these valid? And we're going to append that to the result. All right, append. We're going to append whether they're all valid. Then we can say, are any of the results true? And then we'll know. Yeah. So now we just need to figure out this chopping problem. So we have to address it here as well, I think. I'm happy with what we did here. Here, we need to say, given a message, like there's some matching criteria. I mean, there's no logic here for that. That I haven't encoded that, right? So it's like, for each of the things, we're like calling 2, 3, and then within 2, 3, we're like, look at, okay, is 2 valid? So we look at the 2, and then we're like, okay, with 2, it has 4, 4, and 5, 5. Well, 4, 4, and 5, 5 has 4 and 4, so it's like, I mean, maybe it does come down to just that. Huh. I guess we can try it. You know, we can evaluate one of these inputs. Well, I don't remember which one's right, though. Let's find one that we know is correct. This one is claimed to match. Whoops. All right. Bool is not iterable. It's always nice to see. Yes, we return this, but not the message. Still a little concerned that we don't, like, you know, chop up the message properly. Interesting. How can it be out of range? If the rule is one letter, we didn't check to see if the message was also one letter. So if the message is just one letter, then, well, then we just have letter if message len equals 1, then we only need to check if the letter is MSG at 1. Okay, so that's just message. Is the message that string? And we need to return quote quote. And so it's still saying it's out of range. Huh. Less than or equal to 1? Wouldn't that return false though? Yeah. Okay, the circuit breakers are not stopping soon enough. Alright. And it says false, comma, quote, quote. Oh, because that's what we're returning. Oh, we sliced it to the end. Print message. So we're checking A B A A B A B B B, and so we slice one off. Okay, this is a starting point, I guess. Self.value, self.rulenum. So I want to print this and self.rulenum. So we're checking rule 4. Then we're checking rule 4 again. And let's see, we eventually cut up the, oh, this is only when we get to the bottom. So this should be, Rule 4, rule 4, rule 5. Oh, but we're only checking one thing. So it's like, if there's a, we shouldn't always slice it off. Oh boy. If the rule is down to 1, if it is false, we should slice it. If it's not false, we don't slice it. Right? Yeah. That's what's going on here. So it's like, if the message is 1, then we return whether it's true or not. So let's do this. Valid equals it's true or not. We'll separate the components here. Else we do we want to figure out if it's true or not, separate from everything else. So letter again is the first 0th thing. Oh yes, so the MSG at 0 equals self.value. That's the question here. Okay, and then we say if valid, then MSG equals MSG 1 to the end. Unless the length is 1. Right? Like, if the length was 1, then this won't work. And if the length was 1, we're on like the end of the message, and we should like somehow send some kind of termination signal. Because if the length is greater than 1, we grab the first value. This will never happen if I do it right. If we take the 0th value, we see if it's valid or not, and then, well, no, it could still happen. But if it's valid, we slice it off and we return valid and message. Right, and we're still going to be out of range here. We don't get any further than we did before. We get down to the bottom here and we're like checking if the 4455, geez. If we get a match, we slice it off. We get a match, we slice it off. So at least now we see we get a match, we slice it off. Then we checking these 4 letters, and it's like no match, no match, and then 4455. Huh. Why didn't the first 5 work? Oh, because we're printing it out and then showing the results afterwards. So let's do the thing and then print tab message. So it's like maybe tab message valid also. That wouldn't hurt. All right, so we're checking for rule 4, that's true. Checking for rule 4 again on the shortened string. So then we do 4, 4. There should have some sort of shortcutting here. Yeah, because we're checking all rule set valid append valid, we don't need that. We can just say if valid, if not valid, break. That'll help. So we do A, B, B, and we're like, first one is true, this is what's left, this is false, this is what's left, this is true, and the other one is like if any is true, so of result, when we append this whole thing. So if it is true, then we can just return true. If all in the rule set are valid at any time, return true message. And that should be it. I don't think this should. Whoa. Why didn't it have an error? Weird. Okay. A sliced off. B 4, 4, 5. Why didn't this all get sliced off? Oh, that's concerning. 4, 4, 5, 5, and then it just said true. Okay, I think my short-circuiting did not quite do what we wanted to do. I want every rule in a rule set to be met. That is right. So this is the return. Rule set valid, append true false. Rule set invalid. So this is the rule set. Print rule set. List object has no attribute value. So we do 4. And then print, oh, nope. Print checking self.value. List object has no attribute value. For v in value. Oh. It itself is a list. Oh, because we changed it to a list of lists? Yeah. And so the representation of a single thing is a bunch of kind of different lists at the same time in existence, or different rules, potentially. And so we can say, for each of these rules, self.value, when we assembled this, here's value, we are appending a rule set. So it's always a list, even if there's just the one thing. So we're always going to have a list inside. So for rule in V, why did we go this way of doing it? Let's just do this for now. Oh, crap. String, the list. It's a starting point. I don't know that that's really what I want to show. Got sloppy with this, I'm telling you. Checking self.value. Why don't I just do self.rulenum? I already print that though, don't I? Correct. Checking. Yeah, I already have that up here. So checking 0, which contains 415. So then we go to 4, and that's true. Then we check 1, which leads to checking for 2, which leads to checking for 4, which is false. And then we say correct rule set for 4. All valid rule set. Oh boy. So the rule set all, then we append the valid, whether or not it evaluated to a valid thing. We get the message. If it's not valid, we immediately break, which is happening here because we have a false. So that breaks out of this V in rule set loop. If not valid, rule set.valid append. Oh, but I'm still checking, so I could have a not valid and have everything that's left still be valid. That's problematic. So this should move up. All right, back to the error days. It's good stuff. None type is not iterable. Oh, I got to the what? All right. Checking 0. Oh, do we reset this often enough? Rule set valid. For each thing we append. And when we finish this for loop, if they're all valid, then we say it's correct, which we never say. It's not a good sign, which means we will end up there. Okay. I feel like I'm getting further away from it. Because we have this true, Then we say I'm checking 1, then we say I'm checking 2, and 2 holds 4, which is false. So we short circuit and come back and we get 5. And 5 is true. So it takes 1 off, which is good. And then there were 3. It didn't take 1 off. Oh, right, because 4 wasn't right. So it started out with this. It should be 5, 4, 5, 5. So 5, and then it's this. Then it'll check again. If they're all valid, so if we finish a rule set and none of the rules are valid, that could happen, I guess. Right? Like 5, 5, like might not work out. So we say return false message. All right. Index at 0 is out of range now. So we got further, sliced off the A, BA, BB, BA, BB, took off the B, A, now we're checking rule 3, still checking for the A, we get the A, we take the 4 off, take the A off, and we have BB, get to the 5, take that off, this prints for some reason, and then check for the 2. Because we wanted 2, 3, 2, 3. We have to reinstate the old one? Oh. For each time we get back to this rule set at the top level, message needs to be reset. Yep. Because while I'm down here getting new messages and getting it all chunked up, it's screwing everything up. All right. What should we call it? Original. Okay. Strings are immutable, but the variables that they hold are mutable, and so yabba yabba yabba. All right, and we have this message getting passed in. We save original message. We don't really care about the original message down here because we modify and just return, whereas here we are looping, and so this orig message will serve us greatly. And so now we're going to say message equals orig message, like that. And now we see we go 0, 4, BABB, so B fails, 4, 5 works, 5 fails. Go over to the 3 branch, 4 with the BABB again. The 3 branch fails on the 4s, works on the 5s, and then goes to the 4s, works again, then goes to the 4s on 2, fails, goes to the 5s, works, gets the B's, works, and comes back true and blank. Now, if I call it with an extra letter, this is the thing that I want to test. Do I come back with an A? Yes. All right, so if we come back with an extra letter, then it does not count. So let's do messages. 4, message in messages. base.eval is going to return valid or and the leftover if valid count plus equals 1 and leftover the length is equal to nothing. Otherwise, don't increment that count. Return count. I will print the old contents. Maybe not. 2. Hey, it's supposed to be 2. That's good. That is good. All right, we have a lot of prints to remove, and there are a lot of the. Let's see what else we got. We have this whole true printing business. I think that was up here. Yeah, we have this whole print valid, print rule num. There we go. And after much shenanigans, really hoping we got this part 1 squared away. We got 233. Gotta try it, you know? Whoops. No, stop. Dang it. Typos, yo. Typos. Alright, so we just gotta wait. We gotta wait. Oh, that was brutal. That'll teach them. So, there were so many edge cases on this to like cover for. Like all these any's and alls, and like I guarantee you there was a faster way to do this. This was a ruthlessly inefficient way to do it. I'm gonna wait out my minute. Still don't know if we got it right actually though, so that's fun. Should have hit that stop button on the thing. Answer 2 recently, 10 seconds left. Alright, only got 10 seconds left. Oh man. Sorry folks for the delay. Alright, it is correct. Thank goodness. You know, that would have been terrible. 1 hour and 20 to get through that. Oh wow. Alright. Well. So, what does part 2 hold? Let's take a look. Our matching rules aren't right. We replace rules 8 and 11 with the following. Now the rules contain loops and the list of messages they could hypothetically match is infinite. You'll need to determine how these changes affect which messages are valid. You don't say. Fortunately, many of the rules are unaffected by this change. It might start to help by looking at which rules always match the same set of values and how those rules, especially 42 and 31, are used by the new versions of 8 and 11. Remember, you only need to handle the rules you have. Building a solution that could handle any hypothetical combination would be way harder. For example, without updating 8 and 11, these rules only match 3 messages. Really? Oh, in this whole thing. After, it matches 12. Huh. Okay. This was unexpected, I would say. Yeah. So firstly, they do contain loops. So how do you parse a loop? That's my first question. You like never get to the end. So 8 is now 42 or 42 and 8. So let's find out what 42 is. So this is 42, and 31 is right below it. And I think most importantly here is that it's showing up in itself. Right? So the original 8, oh boy, where is the original 8? 8, yeah, original 8 just had 42, and original 11 just had 4231. So it's got this extra bit, right? It used to be 4231. Now it's 4231 or 42 itself and then 31. So this then could also match 42 again. So this is pointing toward a situation where we would want, firstly, to terminate after a certain amount of infinite looping, but more importantly, we would want to, what does the hint say? It might help to start by looking at which rules always match the same set of values and how those rules are used by the new versions. The rules match a same set of values. So yeah, 42 matches either that or that. And so, like rule 11, or let's do a simpler version here, right? Rule 8 is either just 42 on its own, it's just straight replacement, or itself followed by itself. So it can just like repeat these patterns. The problem is my classes have no way of seeing their parent classes and identifying how big of a loop it's dealing with. And so total of 12 messages mesh. What's notable here is that like some of them are very long, and so the nesting goes for a while. So it's saying it's like 42 followed by either 42 or nothing, or just like more 42s, one after the other. And each of those is one of these, which, you know, cascade downwards. So in my mind, let's see, firstly I want to see if there's some way we can keep track of these loops. Like some outer class wrapper basically that manages these calls, right? To basically say like when I make a new rule based on its number, if I am doing, in this case, right, it'll be like 42, so it'll be like rule 8, we're gonna go create a rule 42 and do the thing, or create a rule 42 and rule 8, which has rule 42. What if we just had a counter that incremented every time we use 11 and 8 and just let it go like pretty far? Oh man. but it like doesn't have to, which is fine, right? Because that's what this OR is all about. All right, first things first, let's update our data. So here's 42. Whoa. Okay. So there's 42. And here's 11. Okay. Second of all, let's update these global counters. This is the dirtiest way in the book to do this. I'm just going to call it tracker. And we're going to have a global tracker here. And we're going to say it's going to be 8 and 11. So it's how many times we've utilized 8 and 11. And so every time we get in here, if rule lookup equals or in 8 or 11, we're going to tracker at 8 or at rule lookup plus equals 1. And at the top of here, let's just say if, I mean, just look at this input data, right? Like how, holy smokes, these are long. Like how long are we talking here? Like this thing is monstrous. So this is, hold up. I think I accidentally typed some letters into my input. Okay, so how long is this super long one? I think that's the longest one we have. So that'll be kind of the upper bound of our test cases. So that's 97 characters. I don't know that we have a good sense of how big most of them are. Based just at a glance, I'm looking at this, right? Do you see the pattern? Like this is like the height of like most of the values. So I'm gonna guess that normally it's around, what is that, 25. So 25 versus, where's that super long one? 97, we said? Here's 89. Here's 89. Here it is. 97. So 25 to 97 is 72 characters. Now, we know that in both of these cases, when we eventually have to break out and go to some of these, right? So like each time it loops, it's going to generate a whole slew of stuff. Either we can actually pre-calculate some of this. 18 is A, so that's a relief. 18 is A, and what did we say B was? 39. Okay, so that means that this then becomes A, this is B, this is B, 83. 83 is this one. Which is 18 or 131. 18 is A. 39 is B. 131 is that. 39 is B. 18 is A. 77 is this. This is what I should have our repra be, kind of. I mean, it'll just end up being A, B, you know, it's the same sort of stuff. Okay, so bottom line is it's pretty long. And both of these have 42s figuring in them. 6. Here's 6. 75. 39 is B. 18 is A. You know, I'm just like going through here, and it's a bit of stuff. 18 is A. 39 is B. 26. 1872 is 1872 A, and then 72 is either A, B, or 66, 18. Oh, we're gonna start seeing repeats, aren't we? But bottom line is there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 at least. Oh, but these are ORs. Oh no. Shoot. So it's actually saying at the shortest. And that's kind of what we have to do here, right? So this collapses to AB. And at the shortest, let's see what 110 is. 10. 18 is A. 39 is B. Gosh. I just could have sworn we already saw 71. No, we haven't. 71 is just straight 66s, which itself is 18 or 39. All right, so this is easy. And then 48 is either A or A. Okay, so 48 is another easy one. So let's just say it's B, B, like we're looking for length here. So this collapses down to just one of those halves. And then this, let's collapse down to the longer of these halves. And then this collapse down looks to be 5-ish, right? At least 5. This got to be at least 4 things. What's 75? Or 123. Another one's great. But bottom line is it's got to be at least A, B in here. This whole thing is at least those 5. This is at least 1, 2, 3, 4, 5, 6. And then we'll have another layer here. And I think at this point, yeah, let's just call it this. So what is that, 8? Oh, not nearly as many as I hoped. So that's like 9 cycles-ish. Call it 10 to be safe. So if any tracker.values greater than 10, don't create rules. Oh man, how do we not create rules? You know? Crappers. It's like, what do we put there instead? You know? You can't just have nothing. We just basically have to count on it never getting there. Like, we'll just say return. Essentially, print depth reached hopefully. And that's it. Just run it. No recursion depth. Wow. Okay. So it sounds like 10 is too many. How about 9? How about 8? Seven? This is going to be one of those things where the recursion depth is too big for us to do it using this approach, isn't it? Yeah. I don't think I'm catching it then. Okay, something isn't working. Print, no, don't print it every time. Oof. Let's go back to 10. And let's say if it's in here, print tracker. All right. So clearly that is a problem. Is that how you do it? Any d.values greater than 9. Right. So how do we go ahead and do it manually? I could have sworn we could have done it better. All right. For v in values, if v greater than 9, print depth reached, return. All right. So since we can go so deep, let's go to 11 and go there. And maybe not. Oh. Makes the thing, and we're like, if rule lookup in R, because then when we do things later, like call eval, that object is still there. It's been created. It just doesn't have anything. What we really want to do is not create that particular rule lookup value. Yes. So let's move this. Yeah. Actually, we don't need to do that. We already have it right here. If this, or if it's in there, and here, if this lookup is greater than 10, then continue. Don't append another thing to the rule set. Yeah. No, out of range. Okay, so now it's still expecting there to be one. No, MSG at value equals value. So this is a situation where we are slicing past the end again. Eesh. So we started off with something really long. And let's do the example first. After updating, for example, let's put our example in small input. Let's run it with small input. And we get 3. after updating, oh, did we? So these are the new rules of the game. Here's 11, and somewhere is 8. After we do it, we go out of range. Okay. So in this example, it looks like A is 1 and B is 14. And when we evaluate a new thing, checking M, so just making sure, that is what we're checking here. So let's put like a checking this, and we're going to start slicing it off. Which print did I turn back on? This one? Not the most useful. It only gets it when it gets to the bottom. I mean, it's okay. Especially given where the error is. It actually kind of makes sense. But really what I want to know is, why am I calling it with nothing? Right? I say, it's the thing, it's the last thing. I'm passing the what is it? MSG at 0 is out of range. I'm printing the message and then the rule number, and there's nothing in the message, so I'm calling eval without anything in the message here, because the message I'm getting back is the original message or the message that's been sliced by eval. Which, let's see. Why do we think that there's a rule 14? That's the thing that's getting me, right? It thinks that there are more rules to be checked, even though I've already, if the length is 1, do that. Here the length is 0, first and foremost. So when the length is 1, do that. Where am I even slicing it off? Oh, right, because it was valid. So then we take it away. And so it looks like we need to go deeper, which suggests that this tracker should go further. Let's just double it to 20. I mean, the recursion depth is enough. Okay, that's not the problem, though. Oof. All right, so it seems like we need a deeper understanding of what's happening here. Okay. Let's play with this example. So we'll go and we will, instead of doing all of that, we will just check this one thing. And do a deep dive. All right, so we're checking this one thing. We're going to print this. We're going to print, we don't need that. Checking. We're going to check this number. And then we're going to say if the rule set is correct, I mean, we know the rule set is correct. Which rule set is the correct one? For V in correct, rule set is correct. Everything in V. v dot rule number. And so then, let's try that. Good. So we got this long string thing that we're inspecting, and we're saying that the rule set that is correct, sometimes it's 1. Let's just see if we can zoom in on what's going on here. Rule set correct is 1. Rule set correct is 3. Oh, you know what would be useful? If we could store one more thing in our class. Let's store the actual R in rule. Right? We get the dictionary, doing all the things. So rule itself. Let's store that somewhere. Self.rule. And so that way we can say down here, firstly in repra, we'll be able to show, instead of a letter, the rule, maybe. Well, let's not jump to there. Let's first get here. Rule set correct is this rule. Alright, rule has no object rule. I should probably also remove these prints of the dictionaries. That is, feels excessive now. So many print statements! Alright. So we're starting, we're checking rule 0, we're checking rule 8, we're checking 42, 9 to 14, 27 to 1, 6 to 14, 14 again. Right. Sometimes we check a thing and it doesn't work out. And sometimes we don't, maybe we don't need this AABB thing. We can just say we're checking this rule and we haven't hit a single correct rule set because V is an object. It has a called eval. Y one, two, three, four, 5 deep. Oh, there's no V. No, that's not the problem. I mean, that is part of the problem because we're outside of this realm, if you will. And it's saying it's all the rule sets are valid. We pinned whether it's valid or not. We got the valid from evaluating each of the V's. But we got each of the V's from this current rule set in self. Oh, let's just do self.rule then. All right, so the rule set that is correct is so let's also show the current message. All right, so man, this is really taking a while. The rule, I also want to show self.rule num. So it's like, what rule set are we checking? And so 0 is 8 and 11. So then we check 8, which goes to 42, which goes to 9. Here we see 9, which goes to 14. 9? It goes to 14 and 27. 9 goes to... Why did it skip 26, 14? Huh. That's odd. 0 goes to 8. 8 goes to 42. We knew that. 42 goes to 9. 9 goes to 14. Why isn't it checking 14? Oh, because 14 is B. Okay, so when it goes to the correct, goes to a letter and it works out, right, if valid, then we say that. Let's go to the top. All right, oh my goodness, this is a really deep recursion, jeez. So we do things like this. We start slicing, we start dicing. Wait, where's the error? I mean, it's still out of range. That part hasn't gone away. And my concern is that the rules, it's like checking 31. 31. You know, there's still like much more of the rules to check, and it's run out of real estate to check it. And we're claiming that, well, we're not claiming that it's right. It just, I mean, it doesn't match. There are more rules here than letters, potentially, because of the... We should have seen that even in this one, because there were like short inputs, weren't there? I guess there aren't any short inputs. And so now we have inputs that are shorter than the number of rules minimally provide? I don't think so. But because of the loops create rule sets that are longer than the strings themselves. And so you can end up in a situation where we say, if it's 1, valid is true. If it's valid, we try to slice it, which could get us in trouble here. That's worth calling out. We may need to, terminate earlier. So if we call eval, we get message, and there's like more to do, do we just return false and like stop? So if you call message with an empty string, I'm going to what? If len of message is 0, return false and quote quote. Like that? Yes, return count doesn't work. I mean, we get false, but like, that doesn't really achieve our goals here either. Let's uncomment some things, because this is a lot of comments, and consider putting a switch in for debug comments, maybe. Just because this turning on and off of the print statements is starting to get tedious. At least we'll put this in just to flag the print statements. Otherwise, I can't even find them. It's just starting to all blur together. All right, we still have this valid, and then the message. This one. And one more. In the loop. 6. It's supposed to be 12. I don't know, folks. It's getting late. I don't know how much willpower I have to figure out what went wrong here. Length of leftover equals 0. The messages that are valid, I mean, we can print them, right? We can see which 6, sorry, not all of them. Print the 6 that we saw are valid. I mean, it's a subset. We got some long ones, you know, ish. But like, hard to say really which ones are which. I'm just looking at the last couple characters here as like a way to fingerprint it. It looks like I was right that this is wrong. There's no, the long one here ends with 3B and then 3 A's, whereas the one here is 4 A's, so it's actually, it is this one. So that's good. But this first one that's like standard length, hopefully we got the 3 that are standard length correct. Abba, Ab, and Baba. And the last one is Ba, which is the one I didn't include. So that's good. And so it's everything in between that's tripping us up. So we know this is good. But this one, it's BA and then 4 B's in a row. Is it this one? So we don't have that here. So it looks like this one ends up false for some reason, and it should be true. Yeah, so that's that string. So let's comment this out. Turn things back on. Let's just give ourselves a little bit more screen real estate here and find the bugs. 1, 2. I mean, I don't want all of them. I mean, I guess we do because we're trying to sort out this one specific example. I'll put it there so I see it next time. So what we're seeing here is somehow we're getting pretty far, and then we run out of characters, it looks like, while still rule checking. We run into this end of string problem that we saw before. This little criteria here. Oh, it's still... No, there's a bug. Yeah, it's still saying out of range. We're not... Oh, man. I mean, I don't know if I have a good solution here, you know? Like... Like, these are so long. And so... it's going to be really tough to pick out what went wrong in the, you know, like it's so long, it's basically not tractable to do it manually, you know? and to discern what exactly it is that's causing, like the only thing I can think of is our reset, right? We have this original message thing that I'm doing at the top of each rule set. So when we parse a certain individual rule, we have kind of some original message that's coming in, and this whole thing, right? If the rule is a string, we do this thing, and basically at the end of it, we're gonna return. So we can shrink that down. And at this point, I'm gonna take that away. And so our result, quote unquote, which we don't end up even using anymore, we have our original message that I've made a copy of. And then we set our message to be that original message each time we go through each set of individual rules that we're going to evaluate. And then we create a list of booleans in which we will store the outcomes of evaluating the message each time. And if it's not valid for a given rule set, we're going to break. And so only if we go through and all of the rules in that rule set are valid, then we will say that rule set is correct. Because everything inside of self.value is separated by a bar, we think. Because even the singular rules that are like this are stored as in the dictionary form with brackets around them. So we saw that in our parser when we went and our parse rule always returned this output, which was a list of tuples. And so even, let's print out what the parser returns here. So even with these errors, like our parser, when we go through it, right, this is a string, but the other things are not. So even when there's only one value, like here, it is a tuple, it is two tuples. So 15 colon was an interesting case because it looks like it's going to be either 1 or 14. And so it will still go through and it'll say, for each of these, we'll have a tuple. And then for each in those, we will go through and evaluate its validity. So it's saying, for each thing in the list, and then for each thing in the rule set, for each tuple, we will go through. Let's see what this looks like. So if we say A is that, for I in A, for J in I, print J, you get 1 and then 14 separately. Which is what we want. And so if A were, 1 and 2, and 14 and 15, then you'd get this. Right. So this is as we would expect. So then we say, each one we're going to append the validity of it or not. Eval returns the message. And then what I'm concerned about is we only reset the message here at the per rule set level. So one rule set will yield one message, like the updated message, right? It's going to get updated for each time it gets called by a message. And passed down, and when it calls a base case, it's like, oh, get me 14 and 39 or 14 and 1, and it comes back and it's like, it's an A or it's a B, and so it'll just say true and slice one off, and so it will shorten that way. So that all seems fine. And so if we go through all of the rule sets, including the, this shouldn't be the edited message, because it will be partially edited. So let's return the original message here. Still breaks, I assume. And so when we get down to the end, we eventually return a message that is blank. And so in this case, we get down and we're like, rule set correct, either this or this worked out. Or I guess one of those two worked out. And so now I'm checking the next one. Really should put rule set here and rule num down there or something. Because I'm checking 11. Why am I checking 11? Oh, because I'm down here? Right, I'm going to put this here for checking. And do it like that. So it's like, A, checking 1 or 14, which we remember 14 is B, 1 is A. So it's like A or B. It's like, yeah, that's fair. It's going to be A or B. Checking 1 or 14. Where am I here? And so in this loop, we say rule set correct. 1 or 4 true. AA. So printing here down to the single letter. We slice one off. And then we check true. And we say rule set correct 15. Rule num dot rule. For rule set value. Rule num is corresponding rule V. We should be showing the V that was the V's that were correct. If the rule set was valid, then this rule set was valid. So it should be rule set. I don't know if I can get away with this. Yeah, for some reason, I end up with this problem. Oh, because it's a bunch of rules, sets. But I want to know which one it was. For a rule set, it's a list that is, it's funny that it like starts working. I guess it's because none of these gets a full rule set correct, and the ones it does, it breaks. So I want to show the numbers associated with the V's in the rule set that worked. So I guess it should be all the V's in rule set have a rule num. Self.value. I have a hack. Enumerate to the rescue. And I'm just going to do self.value at self.rule at I. So we get all the values. The rule is like the list of tuples. And so it will give me the corresponding one that is correct that we're like on. Yeah, okay. So now we can see what's really going on. Rule set correct, 1, and then we say what it is after being correct. Original message. Let's do a little thing saying it went from this to that. Right, so it's like rule set correct 4231, which shrunk it considerably by the looks of it. Then 1417, we return true valid message. Should we say what the rule num is? True rule num message. This is post slice. So it's like this went to that. Then we're checking these two, and we're like 14. Now we're checking these two, which I assume is, see, every time I do checking, that's another function call. Self.rulenum. Finally getting my prints in order though, so that's something. So we're checking, rule 3. So why are we checking rule 3? It's because we checked rule 14. Now we check rule 3, which is this. So then we check rule 5, which is this. We check 1, which is that. So we're splitting down. And then we check, see, we checked 1. What about 14? That was up here. Why don't we check 14 after we check rule 1? But instead we check 15. Something about the way the true-false is short-circuiting I don't like. And then it just says rule set correct 1. Because I was checking 15 and it decided rule set correct was 1 and AAA went to 2A's. And then we checked 1 again. I guess this one? Rule set correct 15 comma 1. Still going from 3. Now we're going from 3 to 1. 15, but that's because it was 15 comma 1, and 15 was either 1 or 14. So I guess that's fair. But there's so much more to check. So what happened here is what I'm most curious about. I think it's mostly a result of what happened above. So after this wave of rule set corrects, we're checking 31. We're saying 31 has these two, which, interestingly enough, we check 1 and 13. I guess we just checked 14 and 17 and got nowhere with it. Would it be worth saying rule set wrong? If all are valid, then we say rule set correct. If one of them is not valid, print rule set wrong. I think we can still show this. This doesn't matter so much. It might be instructive. Let's leave it there. It's interesting that these are blank. Oh, right. So here's 31 again. A, B, triple A. Okay. So rule set was wrong right away. So this was wrong. So now we're on to this one, 113. And since we don't print it at the top of each of these, we don't say anything about it until we then rule set wrong. Then we check 113. So then it's like 113, which was 14 and 3. So 14 and 3. And 3 has 5 and 14. 5, which is 14 and 1, which is 1. And 14, which I think is B, so it's wrong. And so 1, 4 is wrong. So now it tries to check 15 and 1. 15, 1. Or 15 itself is 1 and 14. And then 1 is A, so that's correct. So then it goes up wrong again. So now we're back to where we were. Back up to 15. Oh, look at that. The length. No, it's still good. We're still at the 3A phase here. How did we lose this AB? That's my question. Like between here and here, we lost an A and never quite got it back. So we're checking 113. We say 14, 17 is wrong. 1 is right. And so we slice it off. And then we check 13. Yeah, I guess, it's 1 and then 13. And so now we're over on 13, trying out different threads. And so we might say, well, that's interesting. Rule set correct. Look at that. This all was correct. And then at some point, it says we ran out of string, ran out of rope here. 31. $42, $11, $31. We've seen that before. $42, $11, $31. So that was in the middle of checking. So we concluded that this whole segment was correct. Is that the input? What? Whoa. Okay, that was not the input. However, it sure is an interesting alignment with, where does it line up? Is it this part? So it's saying that this piece is correct. That's this part of the input. Why is it that I only see this portion? And like I have no idea where that points back to. So this unravels to say 16:1, 14:3, 11:13, and then 42, 11:31. And so did it just check 11? And now it's going to check 31? I feel like it just checked 31. Like that was what the bulk of what we just did was. Right here. Checking 31. What is happening? There's something subtle here. Checking 31. And I think we don't have an original message yet. This message is the original message. So, all right. So the checking 31 that happened towards the end here, we already were down to this. And we already concluded that 4231 was correct. All right. So 4231 is this one. So if 4231 was correct, only one branch needs to be right. So if 4231, this bit, this I bet you is the same string as the input that we saw here. Right? Oh, it's actually shorter. Crazy. So if that was correct, it chops it down to this. And then it tries to match what's left to 31. I think one of the problems is that as soon as it overruns the length, it like gives up. And like, well, that's because because it's breaking. It doesn't need to though, right? If the length is 0, we can just return false and like stop checking that branch. Because as soon as we call eval and we get a false, then we break out of this single rule set and and then we move on to the next rule set with a new fresh message. But somehow we're managing not to do that quite correctly here. What's interesting is these statements: a rule set correct, and then nothing. Like, this is definitely longer than some of these. Eight 11. And specifically, I want to make sure that when a branch terminates, it doesn't like cause everything else to break or like blow up. So when we find a true set as being valid in this rule set, we return true. If we never find a set that has all true rules in its various ORs, then we return false. And when we return true, we return the original message. This is the only time we return true. When we return true, we return the modified message. This message has been modified through all the evals and worked in part 1, I should add. So whenever it says checking, it's not going to kind of give us a before and after. And then when it says rule set correct, we can see how the remaining characters have been sliced. And then when the, let's see, different values, slice down, checking for these different rules. So it goes down, down, down. And so there's lots of examples where the rule sets are wrong, but there's never an example where we run out of characters. Because like as soon as we run out of characters here, everything dies. Like it rolls back up and it just rolls over, and it's like, I give up. And why would that be? Like, it's possible it's just this example has like a weird edge case in that caching. So I kind of want to, let's try some other ones to see how they behave. So this one came out to be true. And so we see here it says rule set correct, even though there's nothing left. And so you see these are short. It seems that we don't check bad outcomes too much. Like, we're short-circuiting frequently enough. Is it because when we're short-circuiting on those falses, that if the length of the string is 0, it shouldn't be counted as wrong, but rather that, I mean, we only call this for each of the rules in the rule set, right? So it's like, if it says it needs to be, something and then an A, right? It's not rule set correct from original message to new message. See, this is where I'm concerned, 16 comma, well, what is 16? 15 comma 1 is also, so 15 comma 1 goes to, slices off 2 A's. Okay, so 15 itself is a 1 or a, right, and then 1 is A, okay. And so, and 14 is B, yeah. So 15 is A or B. So this works. This takes us from 3 down to 2. And then 16 is 15 comma 1, 15 1. And we already know that 15 1 is AA. So 16, which is 15 1 comma 1, is going to be AAA. And so it's supposed to roll up, right? Then we get the B is correct, and the A is correct. We just keep adding letters to it. And for some reason, then we check 31. And it's like, why? Why do we have to look for 31 now? Because that rolls all the way up to 14, 11, 31, which it looks like is a terminal, search thing. Like at the top level here, we have checking, and then at some point we get to this. And so we check 4231 first, it looks like. So if 42, and then we got something wrong here. And we're back. Here's 11 again. Oh, it's doing the looping thing. And then here we go, 42, 11, 31. So do we ever have rule set correct 42, 31? Like, that's what I want to know. Because basically with an 11 between, and then it's like 42 and 31, it's basically going to be like 42, 42, 42, 42, and then 31, 31, 31, 31, like that's how this particular rule breaks down, like putting itself in the middle, like does that, whereas this is just 42, 42, 42, 42 repeated. So, but like, each time it's, a repeating 42 isn't actually a repeating 42. This is very interesting. So it's saying rule set correct this whole thing. So it unrolled this whole thing, which itself, remember, is 11, right? 11 can be either this or that. And so by saying that this is correct, what it really is saying is 11, which was probably part of a previous 42, 11, 31. Now it's going to check for 31. And so that's where it falls over. And so it thinks 12 messages match. So like, we know we get a lot of these wrong. But why? False. Oh, and then we return the original message, so we get the string back. So we have another 42, 11, 31 problem here. So here we have a situation where it's cutting it down, and like these are all correct, and it's unrolling, and it's unrolling, and it's unrolling. It's checking 31, and we're out of space. Yeah. So I'm gonna sleep on this, give it some more thought. It looks like we're gonna have to take a silver star on this one, regrettably, today. But you know, thanks for folks who, you know, stuck around or watched some part of it. Hope this was, I don't know, hope this was something. I don't know what this was. This was something. But yeah, we'll come back to it tomorrow. I don't know. I'll give it some more thought. I'm going to avoid looking at too much in the way of resources at this point. But this might be something that we'll kind of tinker on over the course of these final days. Really getting tough now. Jeez. Yeah. So for now, I'll say good night and good luck on your own advent of coding and other coding work. And yeah, we'll see you tomorrow.